Alright, Geometry Kids, this is Mr. Kim. Sorry I can't be here with you today. I've got a conference or a training I need to attend. So here we go. Hope you have your homework out, ready to go. Switch papers. Get your pen out, corrected by top or bottom, CB, and 3, 2, and 1. Here are the answers. Every problem is going to be worth a point, 11 points, 11 questions. So if there's a two-part question like this where there's two answers, or even like number 30, if you miss one part, the whole thing's wrong. Over here, number 15, you don't need the radical. I know it's around to the nearest tenth, but just in case you left it as radical form, there it is. And that's pretty much it. Teacher, please pause the video at this time so that the students can finish correcting their homework. Thank you. Alright kids, let's move on. Hope you have your notes ready to go. We are skipping all the way to lesson 4.8 today, so in 3, 2, and 1. Alright, lesson 4.8, this is the introductions to transformations. There's three types. Think of transformations like if you've ever heard of Transformers, right? The robots in disguise, right? They change shape. Depending on what their original shape was, they change into a giant robot. Same idea, but there's three types. There's a translation, a rotation, and reflection. And you're going to basically learn them today, just the introductory part. So it's the basics, all right? So lesson 4.8, here we go, 3, 2, and 1. Transformations, go ahead and write this word down. We're going to do a tree map. There's going to be 3 branches. So after you write this word down, here are the 3 branches. And the first word that we're going to use for transformations or include is reflection. And then we're going to have a rotation. And then we're going to have a translation. These are the 3 words that we went over in the SWABAT, so not a big deal. Anyway, reflection, rotation, and translation. I'll just give you a heads up. The hardest one is the rotation, so make sure you pay attention right here in this section when I get there. Doesn't mean you don't pay attention in these sections, it's just pay extra attention right here. All right, here we go. What is a reflection? A reflection is something that reflects over a line. So for example, a mirror. When you look in a mirror, you're looking at a reflection of yourself. What's left is now right, right? So your right hand in the mirror is actually your left hand, right? Whereas when you wave your right hand at the mirror, it looks like the left hand is waving. So things switch. It's because you reflected yourself over a line. The line in this case is the mirror. The mirror is a separation between you and your image. It almost looks like the mirror, your reflection is actually behind the mirror, right, looking at you. Same thing when you look at water, your reflection in a pool or things like that. Or maybe there's a calm lake and you're looking at, a nice scene with trees, and you can look in the water and you'll see the same exact trees looking upside down, right? That's the idea. Anyway, a rotation is about a point. So what that means is when you rotate something, you're always turning it, and it turns around a point. The word about is just another word for around. We use about just because we do. But think of the word about face in the military when you learn how to march. When you say about face, you turn around, and you turn around on a point. Your feet stay. All you do is turn. So you're rotating around a point. That's a challenging concept when you see it in action. And lastly, the translation is pretty much just a slide. When you move an object from side to side or up or down, like this cursor here, this pointer, you see how it's moving? It's translating across the entire screen. All it is moving up, down, left, or right, or a combination of both. But it's not turning, it's not reflecting, it's not bouncing, right? It's just moving, and that's what this thing is translating, and that's pretty much the description. So we're going to practice these. We're going to have 3 of the same image, and we're going to basically practice reflecting, rotating, and translating these. So again, these don't have to be a work of art. Here's that line that we're going to reflect over. When you graph, this would be the y-axis. I'll just draw in another line, and then this would be the x-axis down here, like something like that, right? But for now, let's just use this line. So we're going to reflect this guy over this side. So everything's going to flip around. So his face won't flip because it's a circle. His legs won't flip because they're pretty much identical. What will flip is his hand with the little ball. So that's how you reflect. Imagine folding this side here and this side here along this crease, right, or this line, and you would have a mirror image, exact replica of each other, except it's switched around. Rotation, about a point. How do you rotate about a point? That means this point stays, but this entire body will rotate. So I'm going to give you a specific direction. Let's rotate this 90 degrees, and I'm going to say clockwise. So that's the symbol for clockwise. It's going an arrow turning around to the right. So what that means is this shape is going to rotate this way, down. Let me draw a better arrow. There you go. So it's not going to move away from this point. This point will stay, but the whole entire body will rotate down. So think about it. If I draw a little right angle symbol here, don't draw this, just look. Right? It's going to move from here down to here. So he's going to fall face down. But how's he going to look? Well, first of all, this leg is his left leg. Right? It's on our right side, but it's his left leg. So that means because it's attached to this point, it needs to stay attached to his left leg. So the mistake will be to draw it this way. Most students will make that mistake. But if I draw the rest of his body, right, now this point is attached to his right leg. Right here it was on his left side, now it's on his right side. You didn't do that correctly. So what we need to do is erase this. Hope you didn't draw it. And I'll show you. You always start with the rotation point. So if that's his left leg, then that means his left leg needs to attach to the point, just like it did in the previous drawing. So that means his right leg is free, right? His right leg is free over here, so his right leg is free. Next you draw his body, his head, his arms, and the ball he has in his hand. And if you rotate your head a little bit, or your paper, you'll see that it's a 90-degree rotation. 90 degrees because it was perfectly vertical, and now you made it fall this way. Right? And that's the idea. Moving on, translation. Translation means slide. I've already shown you what it means to slide with my pointer. So pretty much you're moving the guy down. Right? It doesn't take a genius to figure that one out. So again, reflection, rotation, translation. This is probably the hardest one for most students. Okay. Moving on in 3, 2, and 1. Let's do this with graphing. Okay, because that's the idea. We know how we can do this more accurately on a graph. So we're going to go ahead and graph these points. So I'm going to start. We're going to graph A, which is 0, 0. There it is. We're going to graph B, which is -3, 0. We're going to graph C, which is -4, 3. And we're going to graph D, which is -1, 4. Once you graph these, we're going to connect the dots. And don't connect them diagonally. Connect them on the outer edges. So A to B, B to C, C to D, D to A. So like this. All right. We're going to translate this. We're going to learn how to translate using this thing called coordinate notation. So you're going to see some directions like this in your homework. Take X, Y, which are these points, and translate them, the arrow, by adding 5 to X and subtracting 3 from Y. So for every single one of these ordered pairs, you're going to do this pattern. Add 5 to the X, subtract 3 for the Y. So in all 4 of these points, you're going to basically use the same pattern, which means everything gets translated the same way. Plus 5 to the right, minus 3 down. When you label your new image, you're going to label the letters with this apostrophe. We call it a prime symbol. So here's your new A, right, where it's going to be 5, -3. Here's your new B. It's going to be 2, -3. Here's your new C, which is going to be 1, 0. And here's your new D, which will be 4, 1. We're going to connect the points again, and it looks pretty much an exact same replica of the original, right? It moved 5 to the right. 1, 2, 3, 4, 5. And then it moved 3 down. 1, 2, 3. So that's how you translate an image with geometry on a coordinate plane. Notice how I told you about these apostrophe signs. So the new image has a prime symbol. You need to do this correctly on the homework, please. It'll be marked wrong if you don't. This whole thing that we just did demonstrated this part right here, where you're moving it by using numbers. That's called coordinate notation. So put a star, put a sign, a symbol, an asterisk, I don't know, something. But that's an important vocabulary word. They're going to move on in 3, 2, and 1. All right, so let's use coordinate notation. We have 2 problems here. 3 units to the right, 4 units down. And number 2 is going to be 0 units and 8 units up. The first pair, or the first section right here, so before the comma, always stands for your X movement. So this is always related to your X, and the second one is always related to your Y, because it's an ordered pair, so that's how we follow the direction, X and then Y. So if we're doing 3 units to the right, literally, to do coordinate notation properly, you take X, Y, and and you're going to translate it 3 units to the right, so that's x plus 3, and 4 units down, that's y minus 4. Pretty basic, right? Number 2, same concept, start with your x comma y. You're taking the original, you're going to translate, move it, by moving 0 units along the x-axis, which means we're not going to move anything, right? No left, no right. So pretty much x all by itself. And then 8 units up is going to be a y plus 8. So you don't have to put x plus 0. Some students think, oh, since it says 0, I got to write x plus 0. Well, let's simplify. X plus 0 is really just x, right? So you don't need the blue part, in other words, is what I'm saying. All right? Not a hard concept. Now that you see it, I hope it makes more sense. Moving along, 3, 2, and 1. So let's complete this translation statement. This is like just completing the sentence, right? So they give you a situation. If 3 comma 1 translates to 5 negative 3, then this point translates to what coordinate? That's what they're asking for. So you just find the pattern between 3, 1 and 5, 3. Literally, just count. From 3 to 5, that's a plus 2. So it's x plus 2. From 1 to negative 3, that's negative 4, isn't it? 1 minus 4 is negative 3. So that means all your y's are doing is being subtracted by 4. So apply that same pattern with your x and your y. So we're going to add 2 to 4, which is 6, and we're going to subtract 4 from 7. So the new coordinate is 6 comma 3. So it's just creating your own kind of coordinate notation either in your head or on paper, and then applying that same translation to another point. Basic. 3, 2, and 1, moving along. All right, last problem. It's going to take a little bit of time, so draw this carefully, please. I'll tell you when to draw, and I'll tell you when not to draw. So here we go. Graph AB and CD. These are going to be segments. And tell whether CD is a rotation of AB about the origin. Give the angle of rotation. So before you even continue writing this sentence down, let's get a coordinate system up. So here it is. These points here are just the ones I'm giving you, okay? And AB is paired together because we want to graph them as a segment, and CD is paired together because we want to graph that as a segment. All right, so AB is negative 3 and negative 1. Oops, going back, sorry. Negative 3 and negative 1. And B is negative 2 comma 3. And let's go ahead and use a straight line tool and draw the line here. Okay, don't like it. One more time. All right. Next, in a different color, I will graph C and D. And C is negative 1, 3. I'm sorry, oops, that's not negative 1. Negative 1 and 3. And D is 3 comma 2. 3 comma 2. And again, straight line tool. Alright, so I need to label these points, so I'm going to do that. So that was A, B, C, and D. So the question asks, after you graph it, is it a rotation about the origin? That means, did AB and CD rotate? So from AB, if you rotate it about the origin, so that means that's your point of rotation. That means that's the point that you rotate from, right? That's the leg in that diagram, the original diagram I gave you, a couple slides ago. If I rotate AB from this point, does it end up where CD is? So here's how you test it on paper. I'm going to use a thing called slope. So what I'm going to do is find my rise and run from A to the point of rotation, or the rotation point. If I count, that's going to be 3, 1. Now, I'm not going to use positive negatives here because positive negatives are going to mess you up. Just count the absolute value. So from A to here, that's a run of 3. From here to the point, that's a rise of 1. So you get a 1/3 or a 3, 1, depending on the way you look at it. What I want to do is apply this 3, 1 rise, but it looks like this shape AB rotated this way, right? So we're going to judge if it did rotate correctly. So if it rotated correctly, that means whatever, if I follow the 90-degree pattern, right, whatever started on this side needs to go up this way. If something started this way, right here, then it needs to rotate down this way. And if I'm following my rotation pattern, then it's going to rotate this way, which is where we kind of get the coordinate plane from, and vice versa. So you keep following this 90-degree rotation pattern. So that means I need to rotate this 3, 1 slope, right, going up now. I'm going to rotate it up. So if I do that correctly, it's going to rotate like this. It looks like a pinwheel, kind of like this diagram over here, right? But some of you are like, wait a minute, run was 3. Well, now your rise is 3 because things are turning, right? So my rise is 3 and my run became 1. And so it matches, right? So using the numbers 3, 1, I applied the same numbers to see if my rotation worked out the same way, and it did, 3, 1. I know it's in different positions, but when you rotate something, things switch around. Top goes to right, right goes to bottom, bottom goes to left. So that's why it's a little harder to see. I'm going to erase this one right here because I tested it, it worked out, and now I'm going to test point B to point D. So here we go. I erased my point of rotation, so there it is. So now let's test B. From B to the origin, or the point of rotation, is a absolute value of 3 and then a 2. So that's my, quote, slope. I'm going to see if this slope of 3, 2 applies over to point D and this rotation point. So if I follow the same pattern, oops, yeah, let's use a different color. Let's use orange. Going up and to the right. So that's an absolute value move of 2, and that's an absolute value move of 3. So look at the numbers. 2, 2, 3, 3. 2 is attached to the point of rotation. 3 is the one that's attached to the point I'm looking at. So it turns out this also rotated a perfect 90 degrees. So to answer the question, give the angle of rotation, the rotation is a 90-degree rotation clockwise. Okay, and tell whether CD is a rotation. So yes, this is a rotation, a 90-degree rotation clockwise. If any of these points did not match up, the 2, 3 pattern or the 1, 3 pattern for the A and C point, if they don't work out, then you would say no. But it did work out perfectly, you say yes. That's pretty much the lesson. If you need help and it didn't make sense, you can go home tonight, watch this on the Haiku page because I'll put it up, and hopefully it'll become more clear. Anyway, good luck, have a good day, and start your homework. Bye.